All right, there are a couple people that still just kind of generally said that they would like to have some help with oxidation numbers. Some people were really specific about the questions that they wanted to review, but some people were not so specific. So next time, please, if you were not specific about which number you want me to do, I'd like you to be that way I can work through some of these problems for you. So this was the guided inquiry. This was the connectivity number 49. I am going to go through, there was a request to go through number 1, and I thought that maybe for a little bit extra support I could also go through number 2. So this is number 1 and 2 on the exercises, and then also number 5 and number 6. Those are 4 problems that I thought would be helpful. This is from the critical thinking questions. So I'm going to call this CTQs 5 and 6, and I'm going to call these exercises 1 and 2. So I'm going to start with CTQ 5 and 6. CTQ 5 asks, which species in equation 1 is oxidized and which species is reduced? Please notice that you have to look a little bit further with some of these activities, that this is going to be equation 1 and this is going to be equation 2. That's what we're going to do for critical thinking question 2. So critical thinking question 1 is referencing this one. So we're going to be looking which species is going to be oxidized and which is going to be reduced. So first thing we need to do is we need to assign oxidation numbers. So here, if we start here with 3 plus, this would be a 3 plus. Here we'd end up with, if we have a oxygen, we'll always take a -2. I'll zoom in a little bit here. Oxygen will take a -2, and then we have overall charge for the manganese will be a -1. So if we have 4 times -2, I'm just going to put that down here, it's going to be a -8. So that means if we have overall charge, we're going to have a +7. And here we have a -2, and here we have a +1. So hopefully that you saw how I kind of got to there. And then we're going to end up here. So here we have a oxygen, it's going to be -2. -2 times 4 again is -8. So the overall charge of this chromium, of this chromate is -2. So that means this needs to be a +6. Then this is a +2. And then you end up with a +1. So looking at the overall, here we went from chromium, you can do this on the side here, I'm going to scoot this over a little bit. Here we end up with chromium, went from +3 to +6. Manganese went from +7 to +2. And hydrogen stayed the same, and so did oxygen. So here we are looking at equation 1. So if we went from +3 to +6, that is a loss of electrons or gain of electrons. Thinking about that. So I'm going to rewrite that here. Chromium went from a 3 plus to a 6 +6. Manganese went from a +7 to a +2. Whoops, excuse me. It's a +6 or 6 plus +7. It's not, I don't care about the format. So if here we increased in number of our charge, so then if we increase the number of the charge, notice that this is also going to be a loss of negative charge, so then it's a loss of electrons. And then this one went down in number, so then this is a gain of electrons. Remember with that trick that I was telling you about, there's 2 ways that you can remember. I remember best by oil rig. Oxidation is lost and reduction is gained. So therefore, if we had a loss of electrons, that means that we had chromium was oxidized and manganese was reduced. So that would be critical thinking question for number 5. Number 6 is asking about the second equation. The second equation is the copper 1 iodide is going back and forth, copper solid copper 2 plus, and then their iodide. So if I was to assign here we end up with a -1. Overall then needs to be a +1. Here we have 0. Here we have a +2. And then this is going to be a +1. Oh, excuse me, a -1. Excuse me on that. So here we have actually two things going on. The iodide is staying the same. And we end up with, here we have the copper. The copper is going to be both in this case. The copper 2, so we went from copper iodide, went to from from +1 to 0, and then the copper also went from +1 also to +2. So this one was went from plus to 0, so then it had a gain of electrons, and here we had a loss of electrons. So both the copper and the other copper both went through oxidation. So as the copper went from the oil, here we have the oil rig, as we went from copper iodide to copper 2, here we had, this was a loss of electrons, and here we went from copper iodide to copper, we then had a gain of electrons. So that one is a little bit trickier, I will say that, but know that this limiting reactant works, not limiting reactant, excuse me, guided inquiry is a little bit tricky, but that's okay. That's why I'm walking through it right now. So here moving on to exercise 1. Exercise 1 it gives us a long list of things that we need to give the oxidation number for each atom in the following molecules. So I'm just going to kind of go through here, and I'm going to follow along with the rules. I'm going to write them down, and I encourage you to kind of go along with me. You can follow along also on your handout. So you've got Br2. Know anything in its elemental state, both Brs in this case are going to be equal to 0. Then we've got Na and Cl. This is going to take the charge of what it is in the halogen group, and this will be +1. So that is what we've got for both atoms of NaCl, or both atoms in NaCl. Then we've got copper 2 chloride. Again, chloride is going to stay the same as the halogen. So we got -1. We got 2 of them, so the overall charge down here, I like to write it sometimes as -2. So then that means this needs to be a +2. So this, in this case, this would be the answer for, this would be the oxidation numbers for copper 2 chloride. This would be the oxidation numbers for NaCl, and that would be the oxidation number for Br2. Oh, it just got a little blurry. There you go. All right, so moving on into CH4. CH4, remember anytime that we end up with a hydrogen that is bonded to a non-metal, that's going to take on the plus charge. And then we end up with, let's say, +1 times 4. Overall charge is going to be +4, and so in order to balance that out, so then carbon, in this case, needs to be -4. So our oxidation numbers for methane, which is CH4, is going to be -4 and +1 respectively. Then we end up with CO2. Remember, CO2, oxygen is always going to take on a -2. And so then overall charge for that oxygen is going to be -4. So then to balance off that CO2, we end up with oxygen, having a +4. All right, so moving on here, I'm going to scoot this over just a little bit. So then we have a silicon tetrachloride. So chloride, again, is going to take on the same thing as for all the halogens. overall charge is going to be -4. So then we need to have silicone having a +4. All right, continuing to move on. Here we've got silicone, and then we've got carbon tetrachloride, -1, and then times, we've got -4, and so then we need to have +4 for that carbon. Ooh, does anybody see the mistake that I did? If you did, here you go. Here's the mistake that I did. Ding, 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 ding. Did a mistake, did a mistake, did a mistake. I'm so sorry. I forgot about our rule. CH4. When it's bonded to a nonmetal, it's going to take on a negative charge. And then that's going to be -4 overall. And we end up with a +4. Sorry about that, folks. So that is this is the true answer for hydrogen. No, I was correct the first time. Oh my gosh. Oh my gosh. Wow. I'm totally, excuse me on this one. I'm gonna double check. Welcome to my having a moment of our oxidation reduction, our redox reaction. All right, I know this is a longer video. I just want to make sure that I am remembering this correctly. I just got a little bit nervous. Yeah, I was, so for example, it says the oxidation number is for hydrogen is usually +1 when bonded to nonmetals and -1 when bonded to metals. For example, metal hydride such as sodium hydride is NaH. I was correct. I just totally second guessed myself on this. I was like, they're negative when they're actually, so please ignore me. All right, one more time. Here we've got CH4. Here we go. It's going to be a +1 when bonded to nonmetals. We have a +1. We're going to then have a overall charge of +4, and so carbon in this case is going to have a -4 charge. Excuse me, I started to second guess myself, as you might have yourself, because you were also maybe doing this problem and that's why you needed help. Welcome to your AP chemistry teacher, learning as well and having a second guess on themselves. All right, continuing on. Then we've got sulfur dichloride. So then we've got overall charge is going to be -2. So then we have our oxidation number for sulfur, in this case, is going to be +2. Last one for number 1 on the exercises is going to be the Br2O. Remember, oxygen's always going to take on a -2. So -2 is then, we've got 2 of those, and then we've got the dibromide, and we end up with a +1. So those are your oxidation numbers for exercise 1. Exercise 2 is going to be a little bit trickier. As we're entering minute 14, I know this might, luckily you can fast forward if you don't need this. Exercise 2, oxidation number for each of the atoms in the following ions. So we're gonna look at some ions, so they're gonna be a little bit trickier. So if we end up with nickel 2+, guess what? Nickel is gonna have an oxidation number of 2+. Then we end up with NO3-. So then we need to, again, going through the same process. There we've got a -2, and then we've got overall charge of -6 for oxygen, but then our overall charge of the entire molecule, or excuse me, that entire ion is going to be -1. So then we need nitrogen, in this case, is going to be a +5. That is a +5, not a +6. So that is for nitrate. Then we end up with CO3, 2-. So then we have, again, here's oxygen, -2 times 3 is going to be -6, but our overall charge of the entire ion is -2, so